Hello viewers, welcome. Let's provide answer to this question under coordinate geometry. So the point P minus 4, 3 and the point Q 2 minus 6 are points in the Cartesian plane. So we have to find the equation of the line PQ. Then we calculate correct to one decimal place the magnitude of the point, the vector PQ. All right. Now to find equation, we need gradient. So we are taking the line PQ. We need to find the gradient that of the line PQ. So the first thing we need to do is to find gradient, which is taken as m, and that is giving us what? y2 minus y1 divided by x2 x1, the change in the y-axis divided by the change in the x-axis. So if we are taking these 2 points, this is the first x, so x1, the first y, y1, second x, x2, y2. So we lift the numbers the way they are, meaning the gradient will be y2, which will be minus 6, already as minus there, then minus y1, which will be 3, divided by x2, which will be this value, minus x1, which is also negative 4. Don't forget, it's a negative 4 from here. This is the minus from the equation. And that can be translated to mean minus 6 minus 3. That gives us what? Minus 9. How do we do that? We maintain the sign, change this to addition, then we change this to subtraction. Meaning this would have been minus 6 plus minus 3. And you have two negative minus coming together, give you still a minus 9. Then this is going to be minus, minus. Since the minus are together, they cancel. Or better still, we maintain this, we change this one to addition, we change this one to addition, just like we did here. So this will be addition, addition, and that will give us a positive 6. So any common factor, I believe 3 can go into that, minus 3, 3 will go here, a positive 2. So this becomes the gradient of the line PQ. We know the gradient, we need 1 point. So using the point, we are going to use any of the points. So I prefer the first one, which is minus 4 and 3. So the equation becomes, we know we have y minus y1 equals to mx minus what? x1, where the x and the y are the coordinates in the plane. Then the x1 is the value we are picking here as minus 4. Then the y1 will be what? 3. So let's do substitution. Y minus y1, which will be 3, equals to gradient, which we found as minus 3 on 2. The x will be there, minus the x1, which is still minus 4. All right. So what do? We can multiply by the LCM because we are having a fraction. So this will become, here times this will be 2y minus 2 times this 6. Then equals to 2 times minus 3 on 2x, negative, negative, give us positive 4. So these 2 will be cancelling this. Then I will be left with 2y minus 6, which will be equals to minus 3x plus 4, right? We need to expand that bracket also. So this will still maintain 2y minus 6, then minus 3 times x, give you minus 3x, minus 3 times 4 will give you minus 12. So we are looking for the equation. We can write all the numbers and the variables on the left equals to 0. Or we can make x the subject also in the form of equation of a straight line. So we are going to write this as 2y equals to minus 3x, maintaining minus 12, we are adding 6 to both sides. 6 plus this will give you 0. But you can add it here as what? 6. So what happened? 2y will be equals to minus 3x, then minus 12 plus 6 will give us minus 6. How do we do that? We are adding integers of different sign. So we are going to perform subtraction and keep the sign of the bigger number. So 12 minus 6 is 6. The biggest number is 12. Has a negative, so negative 6. So we can leave the equation in this form, or we can divide by 2, meaning y will be equals to minus 3 on 2x minus 3. You can see the gradient remain the same. You see the same gradient. So that will be for the first part. The second part, we are to find the magnitude of PQ. So how do we find magnitude? We know the magnitude of PQ is going to be the square root of x squared minus plus what? Y squared. It could be x1 minus x2 all squared plus y1 minus what? y2 all squared. We can do that directly from there. Or we are going to make sure we get one value of x with this. Then x, the y values will also be 1. Meaning I'm going to find the position vector of PQ. Meaning your PQ will be equals to the OQ, or let's say Q minus P, the position vectors. So what is the position vector of Q? We are having it here. So that is going to mean 2 minus 6 is a vector. Okay? So minus P, which is minus 4, 3, position vector. So this becomes 2 minus 4. That becomes 2 plus 6, 2 plus 4. That gives us 6. Minus 6 minus 3. Just like we did in the beginning, that will give us minus 9. So now this becomes the x value. And this becomes what? The y value. So right away, the magnitude of PQ is going to mean x value squared. That will be 6 squared, y value squared, minus 9 squared. So I have 36 plus 81. Don't forget, negative 9 times negative 9 give you positive 81, not 86. Okay. So this will give you, I believe, 20 from here will give us 101. So 117. And the root of 117 will give us 10.816 that way. But the question is asking us to write in one word decimal places. So this is going to be 10.8 units. So that will be 4, the magnitude of PQ. I believe the concept is well understood. Thank you for watching. Like, share, and comment. Bye-bye.